Hello, so today I would like to speak about a feature that is available for crash profiles less than 9 radius, which is called result initializer. So before getting to the point and to the usage of this function, just a bit of context. For at least a decade now, it is quite standard for explicit computation to introduce as initial conditions the residual states, the residual strain values, for instance, for parts who have been submitted to stamping, for instance, or other kind of process. And there are two ways to introduce such residual states strains. First option is to have a second mesh, which is dedicated to the stamping analysis with the original shape of the beam of this part, for instance. And we define the tools, we define the velocity or the displacement of the tools, and then we run the computation, the full computation, generally with explicit schemes. And once we got the results, we map the results from the stamping simulation on the mesh for the crash simulation. Not the most straightforward approach. There's one simplified approach for pre-design, especially, but which has shown really good results and accurate results, which is called one-step analysis. So instead of explicit schemes, we are using implicit scheme. And we're starting from the deformed shape, and the solver, in that case of destruct, is computing from the deformed shape what the initial shape, the flat shape, was looking like, and then identifies the residual states, computing the difference between the initial state and the final state. That said, how do we access to the result initializer? Into HyperMesh, we go to Model, Setup, and Result Initializer. Here we have this GUI, so the first step is to select the folder we want to work with. So let me just go to my folder, Timo models, and I should have RAIT. Okay, just make sure not to have a too long path, and either to have some specific characters into the path. Otherwise, you may have some errors when running the full process. Then you can specify the blank holding force. For this, you can refer to the online help. You will find all the details regarding the different methods. And here at the bottom, you see an option which is add results that includes. So if you're dealing with radius, you will get /initial card written after the result initializer. If you're dealing with LS-DYNA, you will get star initial cards. There are a couple of other options which I will skip. So here I need to select the parts I want to compute. So I will take the 4 parts at the bottom, validate. Okay, what did I do wrong? Let me select again. Validate. No. Okay, so probably this one was already selected. Validate. So which one is missing? Let me do it again. Oh, I guess it would be this one. Validate. No. Okay, let me, sorry, I will hide the geometry. And let's do it again. Add. Okay, now I have my 4. If needed, if you would like to, you can ask for removing the holes from the crash simulation. This is something which is frequently done for the stamping analysis. For the moment, I will keep them. And then you have your different options. So let me put a timer here just to have the option. And let me, so you have the possibility to change the number of cores. On my computer, I have only 4 cores. So let me go to 4 cores. You can parallelize, which means you can parallelize. And what is happening behind the scene is for each of the parts, HyperMesh is exporting a FEM file for destruct with a mesh and a linear material and then running the one-step analysis. So we run as many OptiStruct instances as number of parts to be evaluated. So let me click on initialize, run the timer. You see that the parts were exported, and then we are running the one-step analysis. So let me pause and start again once one step is completed. So the solver is done. Now you can see the model browser is changing because HyperMesh is collecting the include files that have been written out by OptiStruct. And then we're moving to the next step of the process, which is reviewing the results. And for instance, you can review the major strand for one of the parts and see how it looks like. And this for your different parts. Once it is done, and if you identify some unexpected peaks in some location and you would like to do some let's say smoothing, you can define the effective strand cutoff in order to smooth the results and remove the unexpected peaks. And if you do not want to go further, then you're done and your model is done with your include files. So you can go to File, Export, Solver Deck, and I will say Final. I will say Result Initializer. This is the suffix that I generally use for this one. I will say that I want to export. And if you look at the result, you will have one subfolder per part. And here, as I did it for radios, you will have a STA file which contains slash initial card. Again, if you're dealing with LS-DYNA, you will have initial cards instead. So here's how you can deal with the result initializer from the graphical interface. If you want to do it in a batch mode, you can also run in it batch mode in the installation of HyperWorks. So in Altair 23.1 HW Desktop, HM, Scripts, Engineering Solutions, Crash, Result Initialization, Batch. You have a script which you can use. So let me go CMD. Double quotes because of program files. And you can ask for the result initializer.bat, and you can ask for -help, and then you will or -h, or maybe it was just, sorry, it's been a long time since the last time. Okay, here you see, just hit result initializer.bat and it will provide you the needed arguments, so the input tech name, the cutoff values, some arguments regarding the Taylor welded blanks. Do you want to fill the mesh holes with your size limits? Do you want the slash initial or star initial cards to be written as an include? Do you need to run radius? Do you want to run radius just after the one-step initialization? Number of cores? Do you want result file? Do you want the effects due to localized bending and unbending, etc., etc.? So you see a couple of functions, and there should be a file as argument 11, which is a file that contains the list of the entity names to be initialized. So right now, it's the component names. So it's just, if I come back to the model I was dealing with, sorry, this one, I just go to component. My component of interest, this one was one of my component of interest. So if I want to populate this file, it's just going there, picking the name and pasting the name, and then you enter name number 2, etc., etc. So here's how you can work with the result initializer. again, either with the GUI interactive method or batch method, and for the purpose of introducing residual trains for explicit computations. Thanks for reviewing this video. Bye-bye.